Hello, hello, hello. Hello, hello, hello.
Nice.
Hello, Ripriya. Acha. I gave you one question in the last class. Huh? I gave one question in the last class. Could you solve it? This one?
No, sir. I tried solving the previous ones. I'll have to watch the video once again and then I'll do it.
Acha, do you want me to solve?
Yes, sir.
Acha,
Could you explain this?
first tell me what difficulty you will see. What was the thing, na? Till Diva, Radhika won't be joining today because Radhika has exam tomorrow. And Kanishka also. Diva will be joining. See, what is the question? After this, only actually one concept is left, that is toppling one, but that's only as in advanced examination. So let's discuss this question. See, this is a very important one. From this question, you will understand how the rotation works actually. In the arrangement shown in the figure, see the situation, what situation is, this is a pulley. And there is a thread. It is attached to mass m1. It's moving on to this pulley and then again being attached to the m2. Okay. The mass of the pulley is also given to be small m. The thread slipping and friction in the axle of the pulley are absent. Means what he said in this line, thread slipping is absent. It means thread is not slipping. This thread is not at all slipping, means there is a friction between this thread and the pulley. Because of this friction, whenever this thread moves up, the pulley will be rotating. Thread moves up, pulley rotates, and thread with the M2 moves down. Okay. See, earlier, what was the difference with this case and the earlier one in the Newton's law that we used to discuss? What was the difference? In that case, there was no friction between the string and the pulley. And the string used to slip on the pulley and pulley used to not rotate. Pulley was stationary. And just like that, the string used to slip off. Now in this case, because of the friction between the string and the pulley, the string is rotating, string is moving and the pulley is rotating. Understood? In that case, they are asking the angular acceleration of cylinder. Okay, Haripriya, clear? Understood? See now, Diva has also joined. Diva, did you try this question? No.
No, sir.
कोई बात नहीं. I'm explaining it now because this is important one. This is very important because through this only you will understand how the rotation is working actually. In this one, now the difference with the other one is in the earlier type of problem, when earlier you used to solve this kind of question, when rotation was not involved, the tension on the two part was same, but here tension becomes different. Why? Because there is friction involved. Whenever there is a friction between the pulley as well as the string, there is difference in the tension. This is first thing that you should note down in your notebook because you will be using this concept multiple times in rotation problem solving. Whenever there is a friction between pulley and the string, the tension in different parts of the strings are different. Okay, so T1 and T2 are different here. Now what happens? What kind of equations I can make? Even in this case, M1 moves up by acceleration A, M2 also will move by acceleration A because the displacement has to be same. Otherwise, string will be stretching. It is not possible. So the acceleration is same in both the cases. Now, using Newton's laws, we can frame the equation for m1 and m2. It will be t1 minus m1g is equal to m2a, m1a, and m2g minus t2 is equal to m2a. These two are okay. Now, because this pulley is also rotating, it should have some angular acceleration alpha. So what we'll do, we'll make the torque equation about the center T2 into R, which is positive torque, T1 into R, which is negative torque, anti-clockwise. One torque, one direction will take as positive, other is negative. T2 into R minus T1 into R is equal to its moment of inertia into alpha. Now comes, this is okay. Up to here, everything clear?
Yes, sir.
Now, Haripriya, what about you? Okay, na?
Yes.
Now comes the important part. What's the important part here? See, this string is moving down with the acceleration a. So that means the point B, if you take the point B which is on the string, will also have the acceleration a downwards. Okay, we are considering only B. The point B on the string will also have the acceleration a downwards, but the point B also lies on the pulley. So if the pulley is rotating, the B acceleration at B, the tangential acceleration will be A is equal to R alpha, because we have learnt in the pure rotation the tangential acceleration A is equal to R alpha. So because this pulley string and the pulley are not slipping on each other, they are moving in the same velocity, same direction. There is no slipping also. So that means the acceleration of the point B on the string and the acceleration on the pulley point B should be same. That means A is equal to R alpha should be there. This is the tricky part. This you have to identify. You have to get the idea why I am making A is equal to R alpha. Now when this A is equal to R alpha has become, then we can solve these equations 1, 2, 3, 4 to get the value of T1 and T2. I'll show you how to solve it. See, using 3, I have T2 minus T1 into R is equal to mr square by 2 moment of inertia of cylinder, which is pulley, into alpha. R will cancel out. T2 minus T1 is equal to m by 2. R alpha is acceleration. This is my third equation. Now what? Acha. Now what I will do? Now from equation 1, I can write m2 into g minus a is equal to T2. From 2, I can write m1 into g plus a is equal to T1. I'll put these in this. So I'll get m2 into g minus a minus m1 into g plus a is equal to m by 2 into a. So you'll get the value of acceleration, which is m2 minus m1 into g is equal to m by 2 plus m2 plus m1 into a. We've got the value of a. This is m2 minus m1 into g divided by m1 plus m2 plus m by 2. See, initially don't worry. Initially these kinds of questions, you have to just focus on framing correct equations. Once you frame the correct equations, after solving few questions, you'll get how to solve the questions easily. Now, when you have got the value of acceleration, put in any one to get the value of t1 and t2. From this, you have t1 is equal to m1 into g plus a. That means, and t2 is equal to m2 into g minus a. So your what he was asking, t1 by t2. So t1 by t2 value you will get is m1 by m2 into g plus a by g minus a. You can simplify it out if you want. RT by m1 by m2 into g plus a is what? 2m1g plus 2m2g plus mg plus a plus 2m2g minus 2m1g by cancel, then you'll get the answer. 2m1g cancel. 2m2g cancel. So the value t1 by t2 we are getting is m1 by m2 into 2m2 plus 4m2 4m2g, let directly 4m2 plus capital M by 4m1 plus m into g. This one m1 by m2 into m plus 4m2 by m plus 4m1. This is the answer we are getting. Okay, understood? Solving part may be a bit difficult. Whatever. Is it okay now? Haripriya and Diva, we are finding it difficult.
Sir, it's a bit complicated to simplify.
Bit complicated to simplify. Actually, these kinds of
Sir, will
simplification
we leave it as just the expanded form?
equation.
This is there no any is there any other further simplification to that
No.
last answer?
See why this became complex now, because the value of m1 m2 was not given. Usually in the examination, in the questions, when they give you the value of m1 m2 and are those numerical values. So when you put those numerical values, these equations seem easy to solve. These equations are becoming complicated. You're feeling it complicated because I have not given some value to this m1 m2 and capital M. That's why. Don't worry about it. You may be feeling it difficult, but actually when numerical values will be given to it, it won't be difficult. You'll solve it very easily. Just focus on the equation framing. This equation framing, you should be very clear. Okay. Do you want me to give some question? Let me give you some question. Some question to make you feel confident on this. Actually, I gave tougher questions. That's why you may be feeling too tough for us. Even though ultimately you have to become comfortable in this part. Acha, see, try solving this question. Try solving this and then tell me what you understand from this question. After you study it, just study it properly. Take your time. Don't be hasty. Just try to understand. The question will be coming now. Hmm. Just relax, be relaxed, try to understand the question. If you have any doubt in understanding the question, ask me. And if you understand, try to solve. Try to first make the equations and then clarify with me whether your equations are correct or not. Do you understand it?
Oh, yes, like kind of.
Okay. What about Diva?
Yes, I understood, but I wanted to ask that it is written friction is negligible. So when we take it as frictionless,
If the friction is angular velocity, friction is negligible, but it's wound around, no?
mm,
It's wrapped around. So it will be when it will be moving down, it will be unwrapping. Means it's this cylinder is actually rotating. You cannot just take it's the string is slipping. It has to rotate. This question actually has a problem. The friction should not be negligible actually. Friction should be there, otherwise you won't get the answer. Friction, what he wanted to say, na, what he meant, the friction, the negligible part, na, friction at this point, the cylinder and the axis on which it is rotating, in between them the friction is negligible. With the string it has to be there, otherwise not solvable. And one more thing, because it is a cylinder, you have to take its moment of inertia I as mr square by 2. Are you able to? Are you put the charger? It's not charging. Do you want me to solve?
Yes.
See, what he is asking, the angular velocity at time t would be. He's asking. Initially, the angular velocity was 0. Let's say here the tension is T. This part tension is T. So if we see from the front view, this pulley will look like this. this tension. Now, due to this, it will have an angular acceleration alpha because there will be a torque on this. For the mass m, if I draw, this is a mass m, and for this, the tension will be T upwards, there will be mg force downwards, and obviously there will be an acceleration A downwards. So if I make the equations, it will be, one will be mg minus T is equal to ma, first equation for the block. For the pulley, the torque equation T into R should be equal to its I into alpha. Okay, these kinds of equation you should have made by yourself. Now T into R is equal to mr square by 2 into alpha. So we can cancel R. So I'll get T is equal to m by 2 into R alpha. Yes, this. M by 2 into R alpha. Now here, at this particular point, if you see this point, which one? This point. On cylinder, the end A. At this point, the R alpha, its acceleration, which is R alpha, should be equal to the acceleration of the pulley of the block M downwards. So third equation will be A is equal to R alpha. Now using this first, second and third equation, I can solve them to get the desired thing. What I will do, I will try to find out the velocity of the block or the velocity of the string at any time t, and v, because v is equal to r omega, its velocity I'll find here will be v is equal to 0 plus a into t. Okay. The acceleration it has a, v is equal to u plus at. Initially it was at rest. Acceleration a I'll find, which is c. T is, it's easy to find, m by 2 into a. So solve it with the first one. Mg minus ma by 2 is equal to small ma. So mg is equal to m by 2 plus m into a. So from here I'm getting a is equal to 2 mg by capital M plus 2 small m. Okay, I've got the acceleration. Now here in this equation v is equal to u plus at, I'll find out the velocity of this string after time t at this point. So v is equal to 2 mgt by capital M plus 2m. And now because I know v is equal to r into omega at that point, so I'll equate with r omega is equal to 2 mgt by capital M plus 2m. So my answer will be omega is equal to 2 mg t by m plus 2m into r. Means the answer should be t. Actually, if you ask me now, I would have directly eliminated these two options, because r was not there in the denominator. Now ask me where you have doubt, both of you.
So I was able to form the equations, but I
Hmm.
think after that I was feeling a little clueless, like what to do next.
You did not have confidence. A is equal to r alpha also you made, na? If you form the equations, you wanted some time to solve, which I did not give. If I would have given you some more time, you would have solved it completely. So you've got the idea, na? What about Haripriya?
Sir, I didn't form A is equal to R alpha, and I was just keeping T as M by 2.
A is equal to R alpha is the critical one, because using that only you'll relate R alpha with the acceleration. Then only you'll be able to solve it properly. Because why we are doing A is equal to R alpha, na? See, because of the rotation of this pulley, the point A will have the tangential acceleration, which is R alpha, this one. But at the same time, string is moving downward with acceleration A. So the acceleration A should be equal to R alpha for no slipping. Otherwise, if the acceleration of the pulley at tangential acceleration of pulley at that point and the acceleration of the string are not same, they will be slipping on each other. That's the condition. Achha, do you want me to give similar one more question? Then I'll move on to the next concept. Try solving this one.
Yes.
This one is with number values. You try solving this question and make a diagram for the next one. A similar one. What is the question? It's half the moment of inertia. The moment of inertia of the rim of the wheel he is asking. Try solving, and in the meantime I'll draw the diagram for the next concept. Sorry. But this uh, the limit for this notebook, this page. The question.
So I'm getting D.
You're getting very good. Correct. Your answer is this. Correct. Correct. D is correct. Haripriya, are you getting this answer?
So I'm getting 0.5. I don't know.
How?
One minute.
Some mistake you have done. It's the same question, no? See, on releasing from rest, the block falls through 5-meter height in 2 seconds. That means indirectly they have given you the acceleration. Actually, this notebook failing. The acceleration, if you want, see now, the acceleration of this one, if you want, because he has given it falls through a height of 5-meter in 2 seconds. That means what? S 5-meter, S is equal to ut plus half at square you can apply. So using that, 5 is equal to 0, initial velocity is 0, 2 plus half.
So it's 1.5. I have calculated acceleration.
So 10 by 4. That's acceleration is 10
Have
by 4.
written 10 by 4 as 2.
5 by, that's why you're getting wrong answer. Once you get the acceleration, you have to get the after getting the acceleration, you have to solve this equation only. Earlier, how we were solving. Frame the equation. That's the tension is there. Here T, here mg, 2g. So quickly we'll make the equation 2g minus T is equal to 2a, and this is 1. So acceleration is there. So it will be 20 minus 5 is equal to tension T. So the tension you are getting is 15 Newton. Now on the pulley, if you see on the pulley, the tension is 15 Newton. So the torque due to this 15 into R, which is 0.5, is equal to I alpha. But you know A is equal to R alpha. So A is equal to R alpha is there. So you can get alpha value easily. 5 by 2 is equal to, what's the radius? Radius is 0.5. 1 by 2 into alpha. So alpha is equal to 5 you are getting. Put it here. I into 5. So 5 3s are 15. 1.5. So the value of I you are getting is 1.5 kg per meter square. Simply solved. Okay. Now let's move on to the next part. The next part that I'm showing you here now, this is a body, circular body, spherical body, which is moving down the inclined plane. Now for this you have a ready-made formula, which is A is equal to G sin theta by 1 plus I by mr square. But let me show you how do we get this formula. Because see, whenever this body is sliding down, suppose initially you take, there was no friction, it started to slide down. When it is sliding down, the friction will be acting upwards. Let's say it is F. Now because of this friction force, it will start to rotate, because the friction force will be acting a torque on the center, and it will have an acceleration alpha. So when it at the time when it does pure rolling without slipping, you already know this point has an acceleration A. Backward acceleration, it will have R alpha. So A is equal to R alpha is there. So the equations, if I form the equations, there is mg acting downwards. The component of mg is mg cos theta here, and one other component of mg will be here, mg sin theta. And obviously there is a normal reaction also. So if we play perpendicular along the plane, there will be equation mg sine theta minus f is equal to m into a. This is first equation. Now the torque equation, if I make, F into R will be equal to I into alpha. This is my second equation. Torque of friction force about the center, F into R is equal to I alpha. Where don't forget F is the friction force. Mg sin theta minus F is equal to Ma is the normal equation, translation motion equation. Okay. Now, because it is rolling without slipping, I can make another equation also, A is equal to R alpha. Now, solving these three equations, you should get A is equal to this only. Let me show you how we get it. Using A is equal to R alpha, this three, third one, you'll get alpha is equal to A by R. So, from 2, you will get F into R is equal to I A by R. So F is equal to I A by R square. Put this value of F in 1. You'll get mg sine theta minus IA by R square is equal to MA. Acha, here he is taking this. Let me take this as small m, because we have taken the mass as small m for this block, for this rolling cylinder. So mg sine theta will be equal to m plus I by R square into A. So the value of A you are getting here is A is equal to mg sine theta by by m plus I by R square. Divide numerator and denominator by m. So you'll get A is equal to g sine theta by 1 plus I by mr square. This is how you get that result. The important thing is, see, how you got the result. This is actually, they may ask in your class 11 examination, they may ask you to derive this result in your local this CBSE examination. But as far as JEE is concerned, only this result is important. This will solve you. Means only if you want to get the acceleration, just put this formula, put the value of I, whatever body is there, because it may be spherical body, it may be sphere moving down, or it may be a cylinder moving down, or it may be a disc moving down. For everything, the moment of inertia is different. Put that moment of inertia, you'll get the value of acceleration. After you get the acceleration, you can find everything else. Okay. Easy, understood now?
Yes, sir.
Acha, let me give you question then. Toppling is an advanced concept. The toppling concept I'll tell you later. This is the question. Try solving it.
The option
Option
B, 2 4/3.
correct. Diva, you're getting the answer? You want me to solve?
Can you solve?
Acha, wait. Solid cylinder of mass m and radius c, it is a solid cylinder, so the moment of inertia will be mr square by 2. I is mr square by 2 without slipping on an inclined plane of in length L and height h. This is an inclined plane. Its length is L and height is h. What is the speed of the center of mass in the cylinder? It is bottom. Sorry. We know how to find the acceleration. Initially, it was stationary, so u was 0. We know a is equal to g sine theta by 1 plus, what is I? Mr square by 2. I by mr square. So this will cancel out. It will become 2 plus 1, 2g sine theta by 3. This is acceleration A. Sine theta is, we know here they have given sine theta is equal to h by L. So 2g h by 3L is the acceleration A. There are speed of center of mass when it reaches, center reaches its bottom. We'll use that equation v square minus u square is equal to 2ax from A to B along the direction of inclined plane. Here the velocity is v. Here initially it was 0. So v square minus 0 square is equal to 2 into 2gh by 3L into this displacement it has done is L distance. L cancel. V square is equal to 4gh by 3. So V is, we are getting V is equal to root over 4gh by 3. Understood? See, this is how this formula is being used.
Yes, I understood.
Understood? See, one more question I will give you. These are not very difficult questions. These are okay ones. Once you become efficient in solving these questions, you will be able to apply these concepts to solve tougher ones. Okay, try solving this. This is an interesting one. Both the concepts are being applied. Rolling without slipping, rotation down the plane, and without rotation, just sliding. What happened? Could not solve it. See, it's easy one only. When it's rolling down, acceleration A is equal to g sine theta by 1 plus I by mr square. But I don't know you know it, remember or not. I is equal to, for a solid sphere, 2 by 5 mr square. So here acceleration when it is rolling down, it will be g sine theta by 1 plus 2 by 5. That is 5g sine theta by 7. So velocity distance is same. So I can write in the first case v1 square is equal to 2 into 5g sine theta by 7 into x, this distance. Similarly, but in the second case where it is sliding, just sliding down, its acceleration will be g sine theta because it's just sliding down. No? There is no friction also. Only it will be just, it's not rolling, it will be just slipping off downwards, g sine theta, with the acceleration g sine theta, because only mg sine theta is acting towards the incline. Mg cos theta is perpendicular. So in the second case, acceleration will be g sine theta. So in this case, what will be v? v2? v2 square is equal to 2 into g sine theta into x. So v1 square by v2 square that you have is equal to 5 by 7. None of these I'm getting. So v1 by v2.
V1 would be equal to V2 in.
Why?
Oh, 1.
v1 is equal to v2 into root 5 by 7.
Oh, yes, sir.
So none of these.
It will be root 10 by 7. It's none of this.
Root 10 by 7. Why? 2 got cancelled. 2 got cancelled. X got cancelled. X got cancelled. G sine theta, G sine theta got cancelled. 5 by 7 is correct.
Yes, sir.
See, this is the case that differentiate between the two. When rolling without slipping is there, and when it's just sliding, no friction. So rolling comes into picture only if the friction is there. If friction is not there, it just slips down without any rotational motion, only translation. Okay, let's end it then. This is, let me just write it. This is case 1 and this is your case 2 calculation. I'm using v square minus u square is equal to 2as. Here also here. Let's end it. In the next class, we'll start a new chapter, or I'll tell you one small concept of toppling, and then we'll move on. If you want, I'll make you practice more questions. Otherwise, we'll move on to the next topic, either SHM or gravitation.
Bye, sir.
Bye bye.
Bye, sir.
Bye.